Hello everybody. I accidentally closed my test, and so you can go in and look back if you do something like that. It will submit, but so far so good. Let's move on to number 15. Alright, so determine whether the statement describes a descriptive or inferential statistics or statistic. A recent poll of 3,054 corporate executives showed that the average price of corporate executives' car is $49,700. I guess another good thing about going in and viewing, I get the answers there, so I can make sure I get them right. But luckily, I've gotten them all right so far. I guess it's luck. Let's see. Let's go ahead and move on through this. The following bar graph shows the per capita personal incomes for 6 states in 2004. Use this bar graph to answer the questions. So it's probably pretty easy. Find the lowest per capita personal income for the 6 states shown. So I mean, of course, it's just going to be the smallest number, right? So that's New Mexico and 26,191. Find the highest per capita, 35,299, Washington. Looks like you just enter in the number, not the state. Let's see. Alright, this one's going to take a little bit longer because I have to calculate the range. The range doesn't take very long, so the biggest number is 19, the smallest number is 6. So the range is 13. Population variance, population standard deviation for this set of data. Use the rounding rules for calculating variance and standard deviation. So rounding rules are one more decimal place than the original set of data. So you see there's no decimal place, so we'll just put point something. It'll be one decimal place. I did notice this says population variance and population standard deviation. So there's two formulas for variance. One is for sample, one is for population. The main difference for population, whenever you sum up, you sum up all the x minus x bar squared, all of your deviation squared, you sum all those up. With the population, you divide by the total number in the population. So if we have 10 data items, I think we do on this one. That's what that was. Yeah. Then we need to divide by 10. If this was a sample variance, we would divide by n minus 1. So that's the only difference. You do all the same types of calculations. So I'm going to go through this real quick. I've already worked the problem out on the side. So if I go a little fast, you may want to stop and kind of work along with me. The first thing you do is you list all of your values. You don't have to sort these. You can if you want. I would suggest if you have any values that are the same, maybe write those together because that will help a little bit. Because this next column you make is x minus x bar, and so I do need to know the mean of the set of data. I've already done that. If you add all these together and you divide by, I think it's 10, you get 12.8. And so the number here is going to be 6 minus 12.8, 19 minus 12.8. And that's what you want to do all the way down. Okay? And again, if you know how to use one of the TI calculators or one of the fancier calculators, you can just input the set of data and it'll do all this for you. You don't have to list all of this out. And if you own one of those calculators and you want to know how to do it, pretty much just Google it. You can Google a video and somebody will show you how to do variance or standard deviation on YouTube or some streaming service. It's not too hard. Once you learn how to do it, I promise you it'd be worth your time. But all these values that I'm writing down, these are all this x minus this mean. Now the next column, this x minus x bar squared, that's these values, and when I find the sum of those, that's what goes in the numerator. And this is for the variance. And the variance is the standard deviation squared. So if it's population, you have sigma, lowercase sigma, squared. That's population variance. Alright, so you square each one of those. Remember, when you square a positive or a negative, you get a positive. So that makes sure that all of these negative values go away. And this is where you can make a little tiny mistake and it gets your answer off. So whenever you do these calculations, I would suggest double checking as you go, because you can be off by just a tenth or just miss a decimal point whenever you're putting in one of these numbers into your calculator and get the problem wrong. That's why using a TI calculator or one of those other programs is really good, really efficient for these problems. Okay, gotta make sure I line these up. So I think that I got off a number actually. I was just copying from my paper, not paying attention. So I did get off. Okay, so this number is actually for that. This number's for that. This number's for that. Okay, got off a little bit. Sorry about that. Just to save time, I'm going to keep going, because like I said, I've already worked this one out, and I have an answer. We can check and see if I got it right. And so add all of those up, and when you add all of those up, I got the sum equal to 195.6. And so that's what we plug into our formula. That is our sum of x minus x bar squared. That's this numerator right here. Okay, so I have variance equals 195.6 divided by, and since it's population variance, you divide by the number of data items in the population, which was 10 for us. And you can do that division without a calculator. The only problem is you need to round to one place. So we have our population standard deviation is going to be 19.6. Okay. So let's look and see. Was that what we had? Yep, 19.6. Standard population standard deviation. Population standard deviation, its symbol is actually just sigma, and that's because population standard deviation is the square root of population variance. So it's going to be equal to the square root of 19.6. Okay. So 19.6. Oops. 0.6. We'll take the square root of that. And I want to round to one place again. That's the rounding rules, because you do one more than the original set of data. So that's 4.4. Alright, consider a set of data in which the sample mean is 31.6, the sample standard deviation is 7.5. Calculate the z-score given that x equals 30.9. So basically you just need to know the formula for z-score. Z equals x minus mu over sigma. That's for population mean and population standard deviation. So you may be saying, well, these are samples. Well, you can still do that. It's just x minus x bar over s. Lowercase s is sample standard deviation. So it's the same thing. It's just a different symbol. Okay. So mean is 31.6. Standard deviation is 7.5. X is 30.9. 30.9 minus, gotta look back again, let's see, the mean was 31.6. So minus 31.6 divided by, I think it's at 7.5. Alright, so let's do that. Alright, and then z-scores are always rounded to 2 places. That's the way all the tables are that we're going to use, and so just get that in, let that soak into your brain that you always want to round those to 2 places. So this is negative 0.09. Negative 0.09. Alright. Number 19. The following stem and leaf plot represents the distribution of weights for a group of people. So the way that stem and leaf plots work, this is the first number, this is the second number. So this line of numbers actually represents 83, 84, 85, 86, 86. So the next one will be 91, 91, 91, 93, and so on and so forth, even if it's 2 digits. This will be 101, 102, 104, 107. It's just like a way of condensing a bigger set of data into a table that's not as big. Okay. What is the weight of the lightest person in the group? Of course, that's going to be with the 8s and then the very first one. So 83. That's the lightest person in the group. 83. How many people weighed in the range from 100 to 140 inclusive, meaning including those? Okay. So we have 101, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I counted 13. What's the answer? 13. What is the weight of the heaviest person in the range 120 to 129 inclusive? 129 is the most, so the closest or the heaviest one would be 126, right? 126. 126. Alright, determine whether the statement describes a population or a sample. The price of homes of all the employees at the local news network. So since it's all of the employees at the network, that would be a population. If it would have been like maybe the price of the sports reporters at the local news network, then that would be a sample. But since it's the price of the homes of all the employees, it's a population. I hope that the test review helped propel you for the test. Feel free to watch back through it, skip around on the problems that you need help on. If you need any help on anything in particular, send me an email and I'll try to get back with you. Thank you for watching the video and best of luck on your proctored midterm.